project title is Thermal Analysis of Briquette produced from Segregated Municipal Solid Waste. Project members are, team members are Anushya, Dhanasekaran, Sasikumar, Yuvraj. Project guide is Dr. Sumadi Muniyamuthu, Associate Professor, Tech. Today we are facing a major problem in our Chennai city is generating of large amount of waste. Per day, a census says that 4,500 tons per day waste are generating in our Chennai city. This was evidence from Kadungiyur and Perungudi. So now today many of the sources are jumped to some alternative sources because fossil fuels are now going to be decreasing, so we have to find some alternative fuel for our society. So normally there are many alternative fuels are now found that. So a concept is a briquette from municipal solid waste. Now today municipal solid waste generating in our city is residents 68%, commercial 14%, restaurants 11%, markets 4%, hospitals and clinic 3%. So keeping in that mind, these large amount of waste generating in our Chennai city was depleting our land. So landfill is a major problem today in our society, as there was no place. As our Mayor Deresami said that we have to extend the Kodungiyur and Perungudi area sites and extend of area for to fill the dump sites. So this was one of the major problem, right? So everyone is jumping to alternative sources for many fuels. So we are found that we have to replace an alternative fuel for cooking gas, that is LPG. So today LPG was one of the major demand in our state due to its cost and some etc reasons. So keeping in that mind, we are replacing an alternative fuel for LPG. Now project is briquette. So briquette is not a new concept, it is already an existing concept. What is briquette? The briquette is a block of flammable matter. Just imagine that it is like a cow dung that is used as a fuel and to maintain a fire to cook some food. That's it. So briquette is followed in many countries like Uganda countries. So they are followed, and in India also many companies have switched from furnace oil to biomass briquettes. So for using as a fuel instead of a coal. So then in the almost southern parts of India also are following the same. Familiarly, the briquette is going to take a place because it does have a high calorific value, heating value very much, and it has a less carbon emission. So we have done some literature survey papers, and everybody is taking a municipal solid waste. So before that, actually this was a major challenging task for us because last 25 years, very everyone have tried to convert this MSW, that is municipal solid waste, into something fuel that is useful to our society. So many authors have done some different experiments that we go through some literature survey. And first author have take the municipal solid waste like fruit, vegetable, glass, paper, plastic, metals, wood leaf, other materials, and the binder they have taken as cassava, starch, molasses, clay, and they have done a briquette by some process, by crushing process and by mixing with binder and by using a compression pressure at 250 kg per centimeter square, and they have found that the briquette moisture content is 9.84%. Obviously it will burn very much time, and they have found that fixed carbon content is 63.99% and heating value is 4954.62 kilocalorie per kilogram, joule per kilogram, and the CO2 emission find that approximately 1.63% to 5.75%. And the burning life they found that 3 hours, one briquette will burn 3 hours and it will give emission of CO2 1.63 to 5.75%. This was very important. They are taking everything MSW, they are including plastics also. They have found these results, right? Second author have compared the quality of briquette by the machining, that is in mechanical press method how the briquette will be effective, or in hydraulic press method how the briquette will be effective. Of course this is not deal with the briquette, this will tells about the quality of briquette, which will prefer the most preferable method for manufacturing the briquette. So they have done some direct combustion process, pyrolysis process, of course removal of carbon, and they have including some parameters nothing but moisture content, fraction, size, pressing temperature and compacting pressure. So they have taken the raw material as sawdust, bark, straw, cotton, paper. They are using a binder as a paper. So at last, by using this mechanical press method and mechanical and hydraulic press method, they find the quality of briquette is very much efficient in the mechanical press method. For shape and dimension, hydraulic press can be used. So, of course, this is not deal with the briquette emission, but it tells about the quality of briquette which will be more preferable by mechanical press or hydraulic press. Third author have dealt with MSW, same MSW, by comparing the cashewnut shell with the grass and rice as briquette as a raw material. The third author have taken as a cashewnut shell briquette, and they have made some tests, and they have made done some tests like calorific value, shattering indices, tumbling, degree of densification, energy density ratio, resistant to water penetration, water boiling test. So normally there are different types of biomass briquettes are there. Of course, nothing but raw, hydrolyzed, carbonized biomass briquette. So normally other materials are glyceridia, sawdust, and cow dung. These are some materials can be added to make a strength of the briquette. So these are the tests that have been conducted, and they found that they have analyzed the properties like physical properties like moisture content, overall length, diameter briquette, density of briquette, shatter resistance, tumbling resistance, resistance to water penetration. Right? They have found that the calorific value of this briquette is 5154.58 kilocalorie per joule per kilogram. Right. Author 1 have taken the raw material, vegetable, paper, glass, etc., etc. The material they have calculated the calorific value is 4154, right? And the third author have taken the raw material as a cashewnut shell. He found the calorific value is 5154.58, and he find that the carbon content is 19.53. Of course, the fixed carbon content is very much less, where it is not sufficient to burn. But whereas in the author one said that fixed carbon content is 66 point, nearly up to approximate 67%. So slightly increasing calorific value, but of course it will not sufficient enough to burn. The burning life will be decreased. So keeping all in that mind, we have go through such papers, and we kept in that mind everyone are taking the municipal solid waste as a raw material, and they are not excluding the plastics, they are all including the plastics. Today we all know that we have to control the pollution, we have to find alternative fuel. The fuel must not affect our society, and it will be useful for our society. So the main problem is to control emission. So our objective is to keep in that mind is to segregate the biodegradable waste from MSW, aiming at reducing landfill, to blend the biodegradable waste and paper to be converted as a paper pulp. See, we are using the MSW excluding plastics. In that MSW, keeping all waste, we are excluding plastics and take a waste paper as a pulp. That is, we are making a binder as a paper, and we have to check the thermal behavior composition test, and we have to analyze the emission and pollution parameters, and we have to done some experiments. Right. Our manual method is nothing but simple manual method. We have to take some bottle with a height of 40 centimeter, with a height of 50 centimeter and dia of 40 centimeter. Then we have to take a briquette sample powder crushed in the then we have to take crushed sample powder, and we have to mix it with the paper binder. That is a binder which acts as a binder. We have to thoroughly mixed, we have to get a thoroughly mixed. Normally we take a vegetable waste, food waste, fruit waste, we have to dry it for sunlight, with the dry in the sunlight for 3 to 7 days, and then we have to crush it in the powder form. This powder form is mixed with the paper pulp as a binder. Then we have to put into the water bottle. We will give the images that how the steps we followed. Yes, of course, raw material, these are the raw materials we use in the briquette. So these are the steps to be followed here. Take a water bottle, and we have to take the waste paper from the waste itself. It's very important that waste to be soaked in the bucket of water for 2 to 3 days, and next the paper pulp is to be ready. Of course, it takes a 2 to 3 days time. And next we have to cut the bottle shape, and we have to maintain a size of height 50 mm, dia 40 mm. In that mind, we have go through such papers, and we kept in that mind. Right. Our manual method is nothing but simple manual method. We have to take some bottle with a height of 40 centimeter, with a height of 50 centimeter and dia of 40 centimeter. Then we have to take a briquette sample. Sit here, we by the hand. Actually, the steps to be followed here is the leg, but we are just pressing our hand, and we are giving us some pressure to get a briquette product. So here you are seeing the briquette product. We will give an image of a briquette. So imagine the briquette, it will be like a solid form, and it's like a cow dung only. You can imagine it like a cow dung form, right? So already I discussed in the paper, briquette by machining, briquette by which method will give a quality, effective quality briquette. Of course, screw extruder or hydraulic press, mechanical press. But our methodology in machining method, we are introducing a small form, nothing but a shred, which is a machining method. This is MSW waste. We are separating into non-biodegradable, biodegradable. A paper we have to segregate from the biodegradable waste, and we have to put in the shredder. It will be shred, and this shredded powder is mixed with paper pulp, and by the briquette machining we are finding a briquette, right? So some analysis to be done in our briquette, nothing but these are the analysis to be taken in our concept. And we have to do the thermal analysis. So thermal analysis, like we have to find the calorific value, specific heat capacity, thermal conductivity for a briquette, and do the emission test. And of course we are in a basic step of a project, basic a primarily step of a project. We take a sample, and in we are using the went to Anna University, and by using the EDXA analysis, in done EDXA analysis in Anna University, electrodispersive X-ray analysis. Of course we find that we are taking MSW as a raw material except plastics. So we find that the fixed carbon content is comparing to all other MSW waste, because they are all including the plastics. We find that our sample having a fixed carbon content is nearly 67 percentage, and oxygen 28 percentage, which will give a very good proof for us this will burn effectively. But keeping in that mind, these large amount of waste generating in our Chennai city was depleting our land. So landfill is a major problem today in our society, as there was no place. As our Mayor Deresami said that we have to extend the Kodungur and Perungudi area sites and extent of area for to fill the dump sites after the burning of a briquette. And the conclusion is, so normally we know that I already said that today emission is a major problem. So keeping in that mind, have to reduce the emission, and also at the same time fossil fuels are going down. So to replace that fossil fuel, we have to find an alternative fuel, which is going to be very effective for another few years, for another centuries. So keeping in that mind, we are creating some process that is to to avoid a landfill problem in the society, and also making a waste, that is our waste, into some alternative fuel for the cooking gas, as a and a best and effective alternative fuel in the form of briquette. So our mission is to this project our mission is to execute this project successfully, and to give us such a useful product to the society, to make it as a greenery environment. So the further future works to be carried out in the briquette, nothing but emission test, calorific value, specific heat capacity, thermal conductivity. So till now the basic stage we are going in a correct way, which will give a better result for us. So we will give a alternative fuel, best alternative and effective alternative fuel, replacing the LPG gas. So thank you.